All right, the last strategy that we're going to use to solve quadratics is called completing the square. I'm actually going to combine it with square rooting both sides because it's one of the last steps. So completing the square is something that always works for solving any quadratic, but sometimes when there's a leading coefficient other than 1 and b is an odd number, the numbers get pretty complicated with fractions and stuff. And that's why people like the quadratic formula. In fact, the quadratic formula is actually derived by doing this process of completing the square. So we're just going to stick with some easy ones where a is 1, okay, and b is even, so we don't get any fractions. But fractions could show up in this, but completing the square shows up in a lot of future math and a section called conics. In calculus, you may have to complete the square to use substitution when integrating. Just recognizing when it helps you solve things, it's great to know. It relates back to the special pattern that we talked about, okay, with the perfect square trinomials. That's what I'm trying to make. When I say complete the square, I'm trying to make a perfect square trinomial. So I'm trying to use that pattern, okay, that we talked about way back when we did the perfect factoring the perfect square trinomials. We're trying to get this pattern, trying to make this pattern so then we can get it to this form so we can just square root, okay, to get the x by itself. So that's the idea here. So when we do it here, we're at these 6 steps, okay, so let's work through problem 1. We're going to subtract c, so c is 5 here, so we're going to subtract 5 from both sides. We're going to get x squared plus 6x equals negative 5. All right. And now, again, this is only true because there's no a. If there was an a, I'd have to divide by it. But a is 1, so I don't need to divide by 1. Now I'm going to take half of b and square it. So half of 6 is 3. 3 squared is 9. Now step 3 says add 9 to both sides. So when I add 9 to both sides, I get x squared plus 6x plus 9 equals negative 5 plus 9. All right, whenever you do to one side, you do the other. So it's still a true statement. Now this follows that pattern that I was just talking about. This is a perfect square trinomial. So I could factor the left side as x plus 3 squared. And then the right side is clearly 4. And now that there's x there's only one x in the problem, I could isolate it. So I got to get rid of the squared. So I'm going to square root both sides. So I get x plus 3 equals plus or minus 2. Again, because we're solving, so 4 could be either positive 2 or negative 2. And then I subtract 3 from both sides. So again, I'm going to get 2 answers here. All right, I'm going to get positive 2 minus 3. And I'm going to get negative 2 minus 3. So my 2 answers are negative 1 and negative 5. Okay. And since these were integers, I could have solved by factoring on this problem. But I wanted to show you guys completing the square. Let's do one more example of completing the square. All right, so now on this one, the 14 is already over. So I do not need, okay, to subtract c over. It is already over. So I'm going to just go ahead and take half of b, so half of 10 is 5. I'm going to square that. I'm going to add that to both sides. So 5 squared is 25. So I'm going to add 25 to both sides. I'm just going to combine a little bit of work here. 14 plus 25 is 39. So I'm just going to write 39 right here. And now I could factor this side. Okay, so that's x plus 5 squared. And then I'm going to square root both sides. Now 39 cannot be simplified. Okay, so I leave it as plus or minus. We're at 39. And when I subtract 5 over, my answer will be negative 5 plus or minus, we're at 39. Okay. And if you just watched video 12. Okay, this was the problem that you guys just did on your own with the quadratic formula. And so you could see that here was a lot more work to simplify. So completing the square was actually easier here. Okay, but again, it's easy because A was 1 and B was even. As soon as I make that an odd number, now you're going to get fractions. All right, so there's times and places to use each. Okay, now I want you guys to go ahead and try number 8, or sorry, that you try the x squared minus 6x plus 8. All right, and so here we're going to subtract 8 from both sides. So I get x squared minus 6x equals negative 8. I'm going to take half is 6, which is 3. 3 squared is 9. I'm going to add 9 to both sides. Again, it didn't matter that b was negative because as soon as you square it, it becomes positive. So I'm adding 9. That's just 1 right there. Negative 8 plus 9 is 1. Okay, factor that. That's x minus 3 squared equals 1. Square root both sides. So I get x minus 3, and the square root of 1 is 1. So plus or minus 1. And now I add 3 to both sides, so I'm going to get 2 answers. X equals 4, because 1 plus 3 is 4, and x equals 2, negative 1 plus 3 is 2. My two answers are 4 and 2. All right, and I could write them and put the comma there because I'm just listing off my different x's. I could put them in set notation. Right there, I could write it x equals 4, x equals 2. And so there you go.